Okay, so today we're looking at weighted graphs or weighted networks, and then we're going to look at shorted path problems. So what a weighted graph is that when you get a number is allocated to the edge. So the weight can represent a lot of things. It could represent like time, it could represent distance, but what we're saying is we're giving it an edge, like we're giving a number to go on with that edge, okay? So a network is a weighted graph in which weights are physical quantities, for example, distance, time, or cost. So let's have a look at this one. It said the network opposite is used to model the tracks in a forest connecting a suspension bridge, B, a waterfall, and a tree, and a fern gully. Walkers can enter or leave the forest through gates 1 or gate 2. The numbers on the edges represent times in minutes it takes to walk between these places. Okay, so then if we have a look, so you can see it's like a path, and then they're saying the estimated time that it takes. So how long does it take to walk from the bridge directly to the fern gully? So you're at the bridge and you want to go directly to F. So how long does that take? 12 minutes. So we write 12 minutes for that one. Okay, then and then how long does it take to walk from the old tree to the fern gully via the waterfall? So to walk from the old tree, so I'm going to do it in green. Here's the old tree, and you're going to go to the fern gully, but via the waterfall. So the waterfall, you're going to go out here, so that would be 10. Then you're going to have to go to you're going to the waterfall. So you're going to probably go through here. So 9, so 10 plus 9 is 19, plus the 12 is how much in total? Yeah, so plus 9 plus the 12 equals 31 minutes to do that. Okay. All right, so let's have a look at this. A weighted graph in the diagram below shows towns represented by vertices. So the dots are the towns, and the roads between those towns are represented by edges, and the numbers represent the lengths of each road in kilometres. Okay, so how far is it from Strathmore directly to Osborne? 9. So if you have a look, you go over, you want to be at Strathmore and you want to go directly to Osborne. Yep, and we're going to say that would be 9, now it said kilometres, so 9 km. Now the next one, how far is it from Strathmore to Keaton via Melville, then Osborne? So we're going to start at Strathmore, we're going to go via Melville and Osborne, and then back to Kenton. 24. So if you have a look, add up, we've got 8 plus 5, which would be 13, plus 11 would be 24. 8 plus 5 plus 11 equals 24 kilometres. Good. Okay, so what they're going to look at, mainly what we want to do is you'll see this thing called, they'll say the shortest path. So obviously sometimes there's more than one option to get from one place to another, but generally what we're looking at is the smallest, the shortest way, or the quickest way there. Because if you're thinking about if it was a company, say they were delivering, they want to get the quickest way, they want to use maybe the less distance, cheaper for the car and things like that. Okay, so the path that ensures that you have used as many of the smallest edges as possible to get to your destination from a given destination is what the shortest path is. So find the shortest path between town C and town F in the network opposite. So you want to go from town C and you want to get to town F. Okay, so what you can do, they often say these problems, you can just do it by inspection. So that's just you having a look. So if we have a look, I might go along here. So if I go 5 plus 4 plus 7, what would that be? That would be 16. And now can we find, so if I said I went from C to B to E to F, okay, is that going to be, what did I say it was, 16? Is there a shorter one? So if you have a look, is that the shortest path? Let's have a look. I could go, all right, so C to, let's try another one and see what we get. So C to what? To A. So that would be 10 plus this one is 16. I actually think this is, no, this wouldn't be 16. This would be 6, 8. That 8 goes there, and 6. So that one would be, what would that would be? 20. So if you try a few others, you know, like, I don't know, I'm going to go from B to this. I might use that one. So 5 to town B to town A, that would be 12 plus 6, that would be 18. So it looks like I've picked the shortest one in the first go. Okay, so that was 18. All right, so that's that. So you can do it by inspection, but that can be a little bit, when you've got lots and lots of paths, it can be a little bit time consuming, and you just might accidentally not see it. So there is a method to helping you find the shortest path. So we're going to look at this example. So it says find the shortest path between the waterfall and the fern gully in this network. So we've got, here's the waterfall and here's the fern gully. So a method of looking for it is, like, you're starting at the waterfall, you try to look for the smallest road coming out of that, or the smallest time. And that generally can help you. So you still sort of got to inspect it, but let's have a look. So if we go out here, so that would take 8 minutes. And then what about if I go straight to there? So that method, if I did that path, so I went from W to G1 to F, that would equal, what was that, 16. Okay, so let's try another one. So what about if I went straight through? 9 plus 12, no, that would be 21. So that's not any, oops, sorry. I'll do it in red. So that's that one. So W to B to F was 21. What about if I tried, I go, what about this way? 10 plus 6 is 16. That would be 26. No, that's not going to work. And do we see any other quicker way? I don't think so. So what's our quickest way? Shortest path? Yeah. To that one, G1. Okay.